Working with linear equations. Throughout this unit, you have learned how to calculate the slope of a line and write the equation of a line in 3 different forms. But what if you are given the equation of a line and they ask you to find the slope or an intercept? Depending on what form the equation in, the information might be really easy to find. But sometimes it might require some algebraic steps to manipulate the equation into the desired form to answer the question. So here's our first example of that type of problem, where we're asked to find the slope of the equation 6x minus 10y equals 30. This equation is currently in standard form, which can be used to find the intercepts of an equation. It doesn't tell you the slope though, and that's what this question wants. So we have to manipulate this equation using what we know from algebra. So think about it. If it's currently in standard form, which form or forms of a linear equation could help us find the slope of this line? And then which form out of those would be most appropriate for this situation and why? Well, the forms of a linear equation that helps us find the slope of a line right away is point slope or slope intercept. It's right in their names. But for this situation, we're going to want to go to slope intercept because it's easier to solve the equation that's given, 6x minus 10y equals 30 for y. And that would automatically give us the equation in slope intercept form to see the slope. So let's do that now. Let's rewrite the equation 6x minus 10y equals 30 where it's solved for y. So the first step would be to subtract 6x from both sides of the equation, giving us negative 10y equals negative 6x plus 30. And then we would want to divide negative 10 on both sides of the equation, which gives us y equals 3/5 x minus 3. So now we've gone from an equation in standard form to now an equation, that same equation, in slope-intercept form. And this is good now because in slope-intercept form, the coefficient of x is the slope. So the slope of the equation, 6x minus 10y equals 30, is the same slope as the equation y equals 3/5 x minus 3, which is 3/5. So here's a new example where we're asked to write the equation of a line with an x-intercept of 3 and a y-intercept of 9. So right away, since 2 points on the line are given, we can first find the slope using the slope formula. We know the 2 points are 3, 0 from the x-intercept of 3 and 0, 9 from the y-intercept of 9. So using our slope formula, y2 minus y1 over x2 minus x1, we end up with 9 over negative 3, which gives us a slope of negative 3. But this problem does not specify a form for the equation, does it? It doesn't say it wants it in standard form or slope-intercept form or point slope form. So we can select any form that we desire. So if we chose point slope form, we actually have 2 different points. So first, if we use point slope form using the x-intercept and that slope we just calculated, remember m equals negative 3 for this line, our equation would be y equals negative 3 times the quantity of x minus 3. That would be an acceptable answer to the question. But you could also use the y-intercept to write the equation in point slope form. So now the equation would be y minus 9 equals negative 3 times x. So that would be an acceptable answer to the question. Or since we have the y-intercept, we just said, and we have the slope, we could just write the equation in slope-intercept form, y equals mx plus b. An acceptable answer is y equals negative 3x plus 9. So all 3 of these are good answers to this question since it's not specific about the form. Now, we didn't write our equation in standard form. We could have converted it from slope-intercept form, but since it's not necessary, that's just even more extra work. We're not going to do that. We're going to stop. These 3 would really be your best and fastest answers to this question. The last type of question, though, is actually taking our equation and it's specifically telling us to write it in standard form. So this example is telling us to write the equation y minus 8 equals 2/5 times the quantity of x plus 5 in standard form, and we would do that because then we would easily determine the x and y intercepts. So we need to get the equation y minus 8 equals 2/5 times the quantity of x plus 5 in standard form. You can recall that standard form is ax plus by equals c, where that coefficient of xa is greater than or equal to 0. So therefore, we need to use our inverse operations to do that. First, let's get rid of the fraction of 2/5. So we'll multiply both sides of the equation by that least common denominator of 5. That's going to give us 5 times the quantity of y minus 8 equals 2 times the quantity of x plus 5. We'll then use the distributive property to simplify both sides of the equation. So that gives us 5y minus 40 equals 2x plus 10. We'll subtract 2x from both sides because we need the x and y variable terms to be on the same side. And then we'll add 40 to both sides to get the coefficient on the other side, which leaves us with negative 2x plus 5y equals 50. But because we want a to be positive, or is 0, but in this case it's negative 2, so we want it to be a positive 2. So we'll multiply that entire equation, all terms, by negative 1 to finally get the standard form of 2x minus 5y equals negative 50. And now that we have that equation in standard form, we can determine the x and y intercepts by using the fact that the opposite value should be 0 in the equation. For example, the x-intercept we can find by making y equal to 0. So we'll substitute y equals 0 into the equation, which leaves us with 2x equals negative 50. So if we divide both sides by 2, we'll have the x-intercept of negative 25, 0. And then for the y-intercept, x equals 0, so we'll substitute that in for x in 2x minus 5y equals negative 50. So then that leaves us with negative 4y equals negative 50. And if we divide both sides by negative 4, we end up with 25 over 2 for y, making the y-intercept 0, 25 over 2. So no matter what form of an equation we're given, sometimes we have to rewrite the equation in a different form in order to find the information that a question is asking for.